Okay, thank you. I hope you can hear me all right. My name is Wolfgang Gotteshelm. I work as a technology strategist for Dynatrace in the 컴퓨웨어 APM business unit. And I want to talk about how you can keep up with the complexity that Werner mentioned by using the new generation of APM in mobile, cloud, and big data. So let's think about how your applications might have looked like 15 years ago. You had a couple of users that used a desktop browser and maybe a laptop to access an application that is running in your own data center. And there you have full control over the network infrastructure and over the actual machines that are running there. So you could monitor performance by looking at your machines running in your own data center. But then something happened. In 2007, Steve Jobs came and announced the iPhone. And suddenly people not only used the desktop browsers and the laptops, but they use the phone, they use tablet devices to access your application. So you have more users coming in from different devices using your application. And then with the arrival of Android, it got even worse, or better depending on which perspective you look at. But now you have way more users and way more devices that can access your application. So it's not sufficient anymore to just look at the performance in the data center. But what you have to do is you have to start by looking at the performance from a user's perspective, by looking at how your users are doing on their devices that they're using, how your application is performing on the phone, on the tablet. And Dynatrace and 컴퓨웨어 can help you with doing that. So let's look at what types of applications users have on their phones. You can, if you want, use a desktop website on your phone. So you can do that. There are websites that are optimized for mobile devices. So you can use a mobile website to get information on your mobile device. And there are native apps on mobile devices. So you can, for example, download the timetable for the Seoul bus system, which I couldn't read, but at least I could download it. So you can do that and figure out which bus to take. So now it's important to monitor the user experience across all those devices and all those different types of applications. The good news is that with the Dynatrace agent technology, we are actually able to monitor all these different types of apps. So we can monitor the user performance for a desktop website, we can monitor the performance for a mobile website, and we can also monitor the performance of a native app on a mobile device. So we can really look at the performance from the user's perspective, no matter which device he uses and no matter which technology he uses. And we have further improved this approach in our new release that is coming up by also supporting hybrid applications. So hybrid apps are based on a native part on a mobile device, but also use some actual websites. And we are now able to also support, through our agent technology, full 24/7 monitoring for those types of apps. So you get full insight, you get the end-to-end view, regardless of what type of mobile app your customers are using. And that allows you to see, for example, where your users are coming from. So if you look at our world map we have here, we see that users are actually spread out across the globe. So it's important to ensure that all your users get good performance no matter where they are. You can also focus on a particular region. And you can then look at how the performance for those users from this particular region looks like. So here I looked at South Korea, and we see that performance is mostly doing good. A couple of users are having performance problems, so we have to look at that. But that's the kind of insight you can get by using our technology, by using Dynatrace. And then it also allows you to see what did the user actually do. So you can look at what happened on the mobile device, no matter, again, if it's a mobile website, if it's a mobile app, if it's a hybrid app. This level of insight is provided for every kind of app on the device. And not only can you see what happened on the device, you can also see what happened on the back end. So you can look at, if you see a performance problem, was the performance problem located on the device, or was it in the back end? And then you can investigate and do the necessary drill downs to find out where the performance problem is located. That allows you to answer the question, why is my app slow? In that example here, we see that we get the full end-to-end view. We start with the user. So we look at the performance from the user's perspective on the mobile device. And we see how the things that our users did, all the transactions that came out of those user interactions, how they went through our infrastructure, all the way to the back end, in that case, really from mobile to the mainframe. So someone using an online banking application, for example, on his mobile phone might access a mainframe somewhere in the back of the data center. And with our agent-based approach, we are able to see how the performance is doing, if there are any performance issues, and then we're able to investigate where those issues are and can improve the performance for our users. That allows us to get insight like which devices are our users actually using. So we might want to optimize our app for a particular device family, so we can get that information. It's also very important to look at not only the performance, but also whether the app is actually working. So we can keep track of how often is an app crashing, and then also investigate where are those crashes happening. So it's not only important to look how the performance is doing. If the app performs well but crashes all the time, the users won't be happy anyway. So it's very important to keep track of crashes and functional health here as well. And then you can also investigate, for example, how much calls to a backend server your app is doing. So that allows you to see when people complain about bad performance. Maybe it's not the mobile app that is performing badly, but it's just because there are so many calls being made to the server, so the performance is going down because of that. And that's the level of insight that you can get from using the new generation of APM for mobile. Now, it's not only important to look at the actual user's performance, it's also very important to ensure continuous performance by using a synthetic monitoring, like, for example, the APM as a service platform from 컴퓨웨어. What this allows is to compare how the performance of your mobile website and your mobile app is doing, regardless if it's used over a wired network or over a mobile network. So that allows you to continuously monitor the performance of your infrastructure and the performance of your app. So I think that's something that Werner showed in his talk as well. For that, you are able to record the necessary scripts. So you can do mobile-specific scripts with those various tasks like turning the phone, swiping, zooming in, tapping on something. That's the type of stuff you have to do if you want to monitor mobile performance in a synthetic way. And that's what 컴퓨웨어 allows you to do by using the APM as a service platform. So now we've looked at the performance from the end user's point of view using our mobile devices. And now we still have our single data center at the back. And as you see, we have way more users than before. So you might think that could be a problem because we have only one data center. That's exactly the development in the recent years. We have introduced the cloud was introduced. It wasn't us that introduced it, but the clouds came up. There are private clouds, there are public clouds, and there are various cloud services. Like as John mentioned in his keynote, you can use Facebook services, you can use Twitter services, you can use Pinterest, all the type of things. That's cloud-based. And to make sure that your end users are getting a good performance, you have to look into cloud services to make sure that you can provide the necessary infrastructure for your performance needs. If we look at how our application stack looks like, it doesn't really matter whether your application is living in a cloud environment or in your own data center. You always have a network, you have a storage device, you have a virtual machine, and you have your application, the data living on that machine. The only difference here is, and a very important difference to that, is that you can't really control what is happening on the lower end of that stack if you live in a cloud environment, because that's the vendor's responsibility. Depending on which cloud provider you use, you might have to care about the operating system yourself, or someone else might do that for you. But these issues that might occur here have a very high impact on your application's performance, but on the other hand, you lose control over them, because it's not your responsibility anymore. You pay for them, so you also have to make sure to monitor the service level agreements so that if the performance level that you agreed on is not met, you can take the necessary measures. So it is very important not to fully trust the vendor, but to monitor the SLAs you agreed on and get the necessary insight you need also in the cloud environment. So it is very important to keep up with a highly dynamic environment. The good thing about a cloud is you don't pay for a server once and you use it for the next 5 years, but you can dynamically scale your infrastructure as you need it. So it is very important for us to know, for example, how many cloud instances are currently running. Is it one server? Are there 10 servers? Because you pay for them, so you want to know, do I only have the necessary instances running, or am I paying for things I don't really need anyways? Then it's important to know what do those instances access. Are they using a database? Are they using a Cassandra backend? So what are those instances actually doing? And what is the performance? So is it the database access working properly? Do we have any problems with those types of access? We might also want to know which instances are talking among each other. So we have communication between different components in our application, between different services that our components provide. So we have to know who is talking to whom in our environment. How is the communication flow and how much data is transferred? And for that, we have to know how many calls do we have between certain components in our application. And all of that can change at any time because it's a cloud environment, so it's highly dynamic. You can scale it up. You can turn things off if you don't need them anymore. So you need an agent-based approach to keep up with that dynamic factors in a cloud environment. And another very important thing to keep track of is, are there any calls across different clouds? So as we've seen before, you might use Amazon Web Services, you might use Windows Azure, and it can be very expensive if you host your application in different clouds to communicate between these different parts. So you have to be aware of those calls so that you can remove them if they're not necessary, so you can optimize your application to not only optimize the performance, but also optimize the cost on the back end. So here we have an example of how problems in the infrastructure actually affect our performance. That is a different storage backend used for a cloud account hosted in Europe. And that storage backend had a performance issue, and that affected the application issue. So even if you're running in the cloud, you still have to be aware of what's going on in the infrastructure your application is running on. So for that, we need virtualization and cloud-aware monitoring that allows you to get insight into how the virtual machines that your application is running on are doing, if the CPU usage is not too high, if enough memory is available, and so on. So you need an approach that allows you to do that, not even for the things hosted in your local data center, but also for virtual machines running in the cloud environment. So if we look at our users again, we have real users, we have synthetic users, and they access our cloud environment. So usually there are different types of clouds. You have a public cloud, like, for example, Amazon Web Services or Windows Azure. So you pay for infrastructure there to a third-party vendor. And you get infrastructure you pay for. Then there are other clouds. You can have a private cloud, for example. If you don't want to share all your data with the internet, you can build your own private cloud. So you have your own servers, but you can use cloud functionality like dynamically scaling your environment by adding new machines. So that's something you can do in the private cloud. And again, there's a hybrid approach where you use some parts from the public cloud, some parts from the private cloud. So that's then called a hybrid cloud. And again, you still might have your data center at the back. You might still use your mainframe because it worked well. You might still have data that's living in your data center that you don't want to put in a cloud environment, so it's still necessary to communicate with the data center on the back. And with an agent-based approach, you can monitor those different types of environment in a central way, because by using Dynatrace, you can have agents that monitor applications running in those various cloud environments and also applications that run in your own data center. So we have one monitoring solution that covers all your various infrastructures, and it's, again, starting from the user's perspective. So you can combine how the application is performing from the user's view with how the performance looks like on the back end. So now we've talked about the devices that the users can use. We've talked about the necessary infrastructure to provide the performance to our users by using cloud services, by using private clouds and public clouds. And now we want to talk about what's going on the back end, because we still have to take care about providing the necessary performance there. And one way to do that is by using those big data and NoSQL technologies that came up over the last years. So if you want to move away from using a traditional database, you can, for example, use Apache HBase or Cassandra, which is a clustered solution, so you get a higher degree of reliability because it can't fail that easily, and you also get higher performance. It's easier to store large amounts of data there. And again, you need to monitor the performance of those types of backends. So we provide agents that allow you to do that. It's also important to be aware of developments like Hadoop MapReduce, where you can take large amounts of data, split them up into smaller chunks, analyze them, and then combine the results. Of course, you also have to be aware of the performance of those jobs. So they might be running overnight, but you want to make sure that they perform as expected. So what we can provide is a very deep level of insight into the performance of those jobs by looking at the running jobs, for example, the MapReduce tasks that we are using there. So how are they behaving? How is their performance? Still very important to look at the CPU usage, so to make sure that you're not overusing your environment. So we can monitor that, and we can look at the individual jobs. And by, as we saw it before, providing that deep level of insight over the whole infrastructure across the different environments, you can drill into the tasks that are having performance problems and investigate what's going on in there. So if you see that something is taking longer than it should, you have the possibility to look into that and to find out where is the performance bottleneck, what is taking more time than usual or more time than it should. And by that, you can optimize the performance of your Hadoop environment. And another interesting possibility is the combination of the deep Dynatrace data that we provide with Splunk. Splunk is a very popular solution for correlating data from different data sources to provide trending, to provide long-term analysis, to provide dashboards to business owners, for example. And you can integrate the Dynatrace data that we can provide into that. So we are able to provide the deep level insight into performance as we saw it from mobile devices. So you can look at the performance of a mobile app and also in backend applications. So you can monitor Java, .NET processes that are running in your data center or in a cloud environment. You get data from there, and you can integrate that data seamlessly into your Splunk environment. And that allows you to do way better, get way better insight into your performance by correlating the data across different sources. You can do better web analytics by, again, looking at different data sources across a longer time frame. You can do also things like fraud analysis and improve your security by looking at strange patterns that are going on in your application, maybe identifying things that don't work as they should. So the combination of 컴퓨웨어 APM data and Splunk offers whole new possibilities by using the real-time feed capability that we provide to get our end-user performance data into Splunk. So what can you do that? You can enhance your operational intelligence. You can use our stream of user activity like we saw it before for a mobile app, which includes what a user did on his device or on a website. You can analyze that against your customer relationship management system and other data sources you might have included in Splunk. And you can identify important sessions there. So for example, your VIP customers that you want to make sure that they get good performance, and you can understand how they access your system. So how do they use the system, which parts are most relevant to them, because that's where you want to make sure that they get the best performance. And you can build dashboards for your business owners. So you can unlock a whole new level of insight by integrating that user data from Dynatrace into your dashboards here. And what you can also do is you can accelerate the speed that you need for fixing issues. So for triaging issues, for identifying where is a problem, where is it located, what can I do about it, what is going wrong. You can accelerate that again by integrating 컴퓨웨어 APM with Splunk. So you can see how the alerts are generated that are triggered by an impact on the real user experience. You can then look not only at your application, but by using Splunk, you can also include other IT components like a firewall, like a router, for example. You can include that in your analysis as well. You can identify the root cause by doing that and then look for affected users and for affected transactions. Most of the time, a problem that's happening isn't only affecting a single user, but is affecting more of them. And so you want to be aware of who is affected by a problem. Is it a widespread issue in the application? And you can then identify patterns and, again, correlate them with other data sources that you have available. So you can find out what actually happened if it is a recurring issue, so you can take the proper measures to avoid that problem from happening in the future. So just to summarize what I talked about here, we can provide support for optimizing your Hadoop usage by profiling the jobs that you have running in there, by making you aware of performance hotspots that you have, pinpointing them, and to allow you to get to the root cause of performance issues that you have here. Then we help you with accelerating your NoSQL transactions by giving you end-to-end visibility into the data backends that you use here. So you get 24/7 monitoring, 100% of the visibility all the time with backends that are popular like Cassandra, MongoDB, Apache HBase. So we have a great support there that allows you to work on performance issues and identify potential problems here before they start to affect the users. And the last part is to get the awesome data that Dynatrace delivers integrated with the data that is in your Splunk environment. So you can get very rich data by using the end user metrics that Dynatrace provides, integrate them with the user transactions that we see, and then get to a whole new level of business intelligence and operational intelligence. Because you can build dashboards that integrate data from different sources. You can do trending, and you can be sure that all your users get the performance they expect. And if there happen to be a problem, then you can identify that in a very fast fashion and make sure that you find the root cause. And actually, I'd like to thank you for your attention. That's it for my talk about the new generation of APM. Thank you. And